Good morning, everyone. Today's lesson requires you to have watched a lecture video from lesson 3, the one we find in announcement 4. And today we'll continue with that 1.3b, the second half of 1.3. Wait a second, let me mute. And yes, from this 1.3, the second half, we will do the following question. I try to avoid problems that I have done in the lecture. So that's why some of the problems here you see are odd numbers. I try to do even numbers, but at the same time, I would like to also avoid the ones that I already done in my lessons. Okay, let's do number 49. Number 49 in 1.3. Simplify b over a minus a over b, big over 1 over a minus 1 over b. Now, I will use LCD method because in my opinion that's the effective and efficient method. I'll multiply the top and the bottom by the LCD. Then on the top left, when I multiply this by AB, the A will cancel. B over A times AB. The A will cancel, right? We get B squared minus the top right. Oh, yes. Go ahead. Go ahead, Malaki. We have an announcement from our SI leader.
Hi, everybody. If you didn't see already, I have two important links I wanted to share with you. One is a poll for you to decide when I'm going to be holding my SI sessions. So I'm going to be holding 3 sessions a week. There's going to be 2 where I prepare material for you guys. Those are the normal sessions. And then there's going to be one where you can just drop in and ask me whatever questions you need. So try and think about when you'll be able to attend these sessions. I'm going to send a link into the chat. That's a Google form, so you can let me know when is the best time for me to hold these sessions. Another link I wanted to send you guys was an invite to a Discord server that I made for both sections of this class. Right. That's about it. Just think about when you're going to be free to go to these sessions and fill out the poll if you haven't already. Thank you.
Thank you, Malaki. Are these the same links that I have in my announcement?
Yeah, I just wanted to remind everybody, that's all.
Okay, yeah, thank you very much. Yeah, so this link is the same to the one you see in my announcement board. Please, for the one who like if you vote for the SI session one, please only if you plan to come, because what I don't want to happen is you say that I want to come on Monday and you never come, for example, okay, and you basically take away other people's chance. But please come. I mean, okay, please benefit from our service here, especially Mr. Maldonado has been with me for at least 1 year with this class. Okay, now thanks, Malaki. That reminds me of another thing. I think I mean to announce it later on somewhere else, but let me also say it here that I have extra office hour on Saturday, 8 to 10 a.m. 8 to 10 a.m. Only, but you need to tell me, but you need to email me in advance. Let's say on Friday morning. Oh, I'm sorry, on Saturday morning. On that Saturday morning, let's say around 7:30. Okay, so that I can reply you with Zoom link. Okay. I need to announce me this also to my Monday, Wednesday class tomorrow. Anyway, let's come back here to number 49. We did the top left already. How about the top right? A over B multiplied by AB. The nice thing about multiplying D by the LCD is it must cancel the denominator and clean up the complex fraction becomes just regular fraction. So what happened on the top right here, it becomes just A squared. Likewise at the bottom, you will see 1 over A times AB, 1 over A times AB. You cancel the A, we got the B, right? And on the bottom right, we get just A. Yeah, you do the same procedure again. Okay, now at least now we still have fractions, but not complex fraction anymore. Not complex fraction anymore. You see that? Okay, it becomes just a regular rational expression. Then from there we go on. On the top, it happens to be difference of squares. So b plus a times b minus a divided by b minus a, that will be b plus a. Okay, or it is possible the textbook, I don't know, but I mean, it's possible a textbook actually write it as a plus b. But addition is commutative, so it's either way. Okay, that's for number 49. Now, number 51 is actually a very similar question to number 49 with extra emphasis. How to deal with negative exponent. Y to the negative 1 plus x to the negative 1 divided by xy to the power of negative 1. Now, what I will do first is to rewrite this expression into complex fractions. Okay, y to the negative 1 is 1 over y. X to the negative 1 is 1 over x. I'm recording this. Okay. And then the denominator is 1 over xy. Now, why I want to go over this question, because I have seen some people misunderstood this as, oh, y to the negative 1 on the top, to make it positive, I put it at the bottom, plus x to the negative 1 at the on the top, bring it to the bottom, and then this is x, y, like that. No, it's not. It's not correct. No, it's not. Okay, this is a wrong answer. That's not the right one. Okay, let me go on. Then after we rewrite it into complex fractions, basically get rid of the negative exponent, but then the consequent is complex fractions. Now get rid of the complex fractions. I multiply by the LCD on the top and at the bottom, which I think just one single step from here. That will give me on the top, that will give me x plus y over 1, which is just x plus y. Okay, that's for number 51. Now, I did 3 or 4 problems with complex fractions in my lecture, so I don't want to do too much here. I will do one more, number 58, which I saw not covered in my lesson, number 58. X plus 2 over x minus a plus 2 over a big over x minus a. Now, you will see this expression later on, actually an important part of our, at the very beginning of calculus, okay? Now, the LCD is x and a and x minus a. So x times a times x minus a. I think it's supposed to be ax, but that's multiplication, it's okay. So I will multiply the top and the bottom by x times a times x minus a. Now then, let's see. This guy multiplied by this, we will cancel the x, right? We'll cancel the x. So we will get a times x plus 2 times x minus a. And then the top right, and multiply by this, the a cancel, so I will have x times x minus a, x times a plus 2 times x minus a. Oh, you know what? I'm sorry. Actually, no. X minus a is not. No, 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 no. I make a mistake. A very big mistake instead. No, 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 no. I don't need this. The LCD is just XA. My bad. So no, 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 no. I have to redo everything. Yeah, just XA or AX, because this is basically x minus a over 1, right? Okay, so no, 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 not x minus a, just x and a multiply. Okay, so on the top left, now this is a lot easier. So this is a times x plus 2 minus x times a plus 2 over ax x minus a. Oh, almost. Almost. See, if you overthink that and you overdo it, then it becomes so nasty. Okay. And from here it becomes a lot easier. So what I will do, I will distribute and combine like terms. This is ax x minus a. Okay, the ax cancels, so I have 2a minus 2x big over ax times x minus a. Oh, but I can factor the 2, right? So I factor the 2 times a minus x over ax x minus a. Now notice that a minus a is the opposite of x minus a. A minus x is the opposite of x minus a. So I can cancel these, but with one opposite. Okay. And in the end, I will get negative of 2 over ax. Okay, that's for number 58. Let's do more. Number 61. We'll do it next year. 61. How about rationalizing denominator? If we have radical on the denominator, and on the denominator we have two terms. Let's say on the denominator we have radical t minus 5. Then I will multiply by the conjugate, square root of t plus 5. That's the conjugate. Okay, now what's the reason we multiply by the conjugate? So that we can make use of difference of squares. So this will become square root of t being squared minus 5 squared. Right? Do you see that? Blah minus blah, blah plus blah is blah squared minus blah squared. Okay. Now, of course, if you can skip this step and then just go ahead with t minus 25, you can, and I think you should. Okay. Now, on the top is the one we need to focus. Okay. That will give us t plus 10 square root of t plus 25. I hope you notice that the numerator is actually a perfect square, right? It follows a plus b squared, right? Which is the first term squared plus twice the product of the terms plus b squared. So that's what I did there. Okay, that's for my number 61. Rationalize the denominator if we have square root multiplied by the conjugate. Now the thing is, number 63 is slightly different. I remember I did number 64 in my lectures. So number 63 is the similar idea, similar method, cube root of a minus cube root of b. Now, how to get rid of cube root if we have two terms? Now, we will multiply the top and the bottom by the one that make it a difference of cubes. Okay, now let's see difference of cubes. X cubed minus y cubed is equal to x minus y, x squared plus xy plus y squared. Okay, now what we have here, we have cube root in this form here. Okay, so I need to find what will the corresponding expression for these here. Which will I copy also to the top. Okay, that's what we'll do. Now, let's see what are those terms. Suppose the x is square root of cube root of a. If x is cube root of a and the y is cube root of b, then the x squared will be cube root of a being squared, right? Because x is cube root of a and the y is cube root of b, and y squared will be cube root of b squared. And that's why the hint in our textbook is multiply by this. Okay, that's the missing factor to invoke difference of cubes. So from here, I will multiply by cube root of a squared plus cube root of a times cube root of b plus cube root of b squared. Now, because I multiply that on the denominator, I need to do likewise on the numerator to keep it equivalent fraction. Then what I have on the denominator becomes difference of cubes. Okay, difference of cubes of cube root of a and cube root of b. That way we cancel the cubes. Okay, now while on the top we have cube root of a being squared. Now, cube root of A times cube root of B is cube root of AB plus cube root of AB plus cube root of B being squared. Okay. Then one more step. Now cube root of A being squared is cube root of A squared. And cube root of B being squared is cube root of B squared. While at the bottom, we have only A minus B. That's the simplest form. Okay, that's for number 63. Number 70. Number 70. I remember I didn't go over this part in my lecture. So let's do this one. The question is expressed as the sum of terms of the form ax to the r. Express as sum of terms of the form ax to the r, where the r is a rational number. Oh, I'm sorry. No. Rational is not rational is q. So q is the set of rational numbers. So it's okay to have negative exponent for this number 70, okay, because they want us to write it as the sum of terms in form of ax to the r. We have x squared plus 4x minus 6 divided by square root of x. Now, basically, I will divide by square root of x. I don't like square root of x, okay, especially because that's a square root at the bottom, right? Okay, so let's separate them, and I will rewrite that square root of x as x to the 1/2. Then we will get x squared divided by x to the 1/2. We subtract the exponent. We get x to the 3/2. X divided by x to the 1/2 is x to the 1/2. And the last term, this is 6x to the negative 1/2. Now, it is not a common situation to have negative exponent in our answer, but here they want us to write it in form of coefficient times x to some exponent, right? So the last term here is the one they want. Basically, they want it in terms of ax to the r. Okay, so this question is actually not too hard. You basically split it and then simplify further. Okay, now let's bring it to number 72. Number 72, is it right? Yeah. Okay. Number 72, we have the quantity of x squared minus 3. I'm sorry, the quantity of square root of x minus 3 being squared divided by x cubed. What we will do, we will FOIL the top first, which will give us x minus 6 square root of x plus 9. I hope you get used to this though. I hope you get used to this. Square root of x minus 3 squared. The first term squared. minus 2 times the first term, the second term, plus the second term squared. Okay, I hope you can do it faster right now. Divided by x cubed. Now I will split them and rewrite it into rational exponent, especially for the second term. So we end up with x to the power of negative 2 minus 6x to the power of negative 5 half plus 9x to the negative 3. Okay, that's if we want the expression in terms of ax to the r. Now, the purpose of us learning this is to learn to simplify the following situation. Number 76. Suppose I have on the other way x to the power of negative 2/3 plus x to the power of 7/3. How do we simplify this such that we have no negative exponent? What we will do actually follows the following situation. So we look back a little bit. Suppose I have 3x to the 5th plus maybe 7x squared. The way we simplify this is we factor the lowest exponent out, right? So we factor the lowest exponent out, x squared comes out. Okay, so I get x cubed plus 7. Are you with me? We factor the smallest exponent out. Now, looking back into the second, on this question here, the lowest exponent is x to the negative 2/3. So I factor that out first. Okay, now then the first term becomes 1 plus, now what is the exponent here? What is the exponent there such that, x to the negative 2/3 times that x to question mark equals to x to the 7/3. What is that question mark supposed to be? But to answer that, we need to know negative 2/3 plus what equals to 7/3. Right? Because the product of same base, we add the exponent. Right? So that question mark will be 7/3 plus 2/3, right? Which is 9/3 or simply 3. Okay, so this will be x to the third. But Thomas, we still have negative exponents. That's true, but it's only one guy, one factor, and I can easily bring it to the bottom. Now I have x to the positive 2/3 at the bottom. Okay. Now, this is how I will do it though, but I think our textbook or somebody else may approach it slightly different ways. Let me show you the other way to do it. The other way to look at that. So you may just rewrite that into 1 over x to the 2/3 here. X to the 7/3. And then you do LCD. So you multiply the second term here by x to the 2/3 at the top and at the bottom, such that you have 1 over x to the 2/3 plus x cubed over x to the 2/3, and then once they have LCD, you put them together. So you still come up with the same answer. Okay. So you have two different ways to do this. I prefer the first one though. And the main reason why I prefer the first one is because if we look at the combo part right after that. So after that, number 76, number what? Number 80. Number 80. This is the combo. Like whatever we learn in this section put together. The monster part. Number 80. 3x plus 2 to the power 1/3 times 2 times 4x minus 5 times 4 plus 4x minus 5 squared times 1/3 times 3x plus 2 to the power of negative 2/3 times 3. That's a long one, huh? Okay, let's see what's the common factor first. Okay. Or the smallest exponent. For the yellow one, 3x plus 2, the smallest exponent is negative 2/3. So that's what I will pull out. Okay, so 3x plus 2 to the power of negative 2/3. Later on inside, on the second term, no more yellow one, right? Because to the power of 2/3 already comes out, right? Okay, but what happened to this one here? That will be 3x plus 2 to the power of 1. Why to the power of 1? Negative 2/3 plus what equals to 1/3. So that what is 1/3 plus 2/3, which is 3/3, which is 1. Okay. And then the constant, to be more precise, the coefficients, nothing in common. This is 8. Actually, this will be just 1. So let me just write that 8 here. Okay, and 1 here. Okay, that's the blue part. This is the yellow part. Now the green part. 4x minus 5 and 4x minus 5 squared. The smallest exponent is 4x minus 5. That's what I pull out. Because I pull out 4x minus 5 to the 1 out, then in the first term, no more, right? I have only 1 left. Okay, and the 1 here will be 4x minus 5 to the 1. To make it square on the second term, right? Write that 1 here. Now then I will have 3x plus 2 to the power of negative 2/3. Later on I will bring it to the bottom. And then I have 4x minus 5. Now the guy inside the parentheses, inside the bracket here, I will distribute. That will be 24x plus 16 plus 4x minus 5. Then the negative exponent, I bring it to the bottom. 4x plus 5 stay on the top. I'm sorry, 4x minus 5. And then I will get 28 x plus 11. It's quite complicated, right? It's definitely not something we can do by just looking at it.
Are we gonna do another example like this? Because
I will.
yeah, where did the 3x plus 2 to the 1/3 power go? Like she just disappeared, or I don't know. Sorry.
X to the power of what?
3x plus 2 to the power of 1/3, like in number 80. Like where did she go? She's just gone.
Well, it won't be. It won't be. You see that it's actually this one here. If you multiply this, it will give you that.
Okay.
Right. It's basically, here's the thing. Is that hold on. You can ask me a question, but you will never get the answer if you don't give me a chance.
Okay.
So x to the power blah to the power of 1/3. If I factor blah to the power of negative 2/3 out, then the remaining has to be here, right? Okay. So x to the power of negative 1/3 2/3 times blah to the what give us blah to the power of 1/3. So negative 2/3 times what give me 1/3. Sorry, plus, because we multiply the same base, so we add the exponent. Right now, then this guy here is 1/3 plus 2/3, which is 1. So this one here now come here. We get used to factor an integer out. Now we factor similarly, but the number instead of integer, we have fractions. So let's try a simpler version of this. Let's try a simpler version of this. I actually did the computation up here. So suppose, let me use blue. Suppose I have x to the power of 3, y to the power of 4, and then plus x squared, y to the 7. Now, what's the common factor?
X squared,
Y
y
x
to the
squared.
4th.
Y x squared.
Because it goes both into x cubed and x squared.
That's right. Or another way to say that, because the exponent is the smaller. Right?
Mm-hmm.
Okay. Okay. And then y to the 4 also, because y to the 4 goes to y to the 4 and y to the 7. Or another way to say y to the 4 is the smaller exponent. Now, then, what left on the first term?
X.
Why? Why only x?
Because you factored out the x squared, so that leaves x within the x cubed.
That's right. So in other words, x squared times x give me x cubed. Right?
Mm-hmm.
I just rephrase what you say, but I rephrase it in a way give us a method to get that x. So 2 plus invisible 1 give us 3. Right? Okay.
Mm-hmm.
And then what happened to the y? Because I took y to the 4th out, so I just need 1 there, which we usually don't write at all. Okay. And then x squared already comes out. This is just 1. And then this is y cubed. Right? Which we simplify to be, usually we skip the second step and just write it this way. See, right? Okay, that's how we did it before. Now, let's change the question a bit further into some negative number. So if I have x to the negative 3, y to the 4, plus x squared, y to the negative 7. So what comes out?
I don't know.
Smaller exponent. Smaller exponent. Right? So x to the negative 3 comes out, and y to the negative 7 comes out. Remember we said earlier why those numbers x squared comes out and y to the 4 comes out.
Mm-hmm.
Right? Okay, so then x to what power here such that x cubed times x to what power give me x cubed negative 3. I'm sorry, x to the negative 3. In other words, to simplify that, negative 3 plus what equals to negative 3?
0.
0. X to the 0, which is just 1. And how about the y to the 4th? Y to the negative 7 times y to what power equals to y to the 4th? Negative 7 plus what give you 4?
11.
11, that's right. Continue. X to the negative 3 times what give you x squared?
Negative 5.
Not negative,
Oh, 5.
just 5. Okay, and then the y to the negative 7 times 1 give us y to the negative 7. Then from there we go on. So this is the kind of like the things you do in your, the one I erase here is the one you do in your, you do mentally. Okay, now of course that mental work will get a bit tedious once we deal with fractions. So the top I have y to the 11 plus x to the 5th, and because negative exponent I bring it to the bottom, x cubed y to the 7th. Okay, now let's go on further. The same situation, but now I change that to fractional exponent. Let's say x to the power of 2/3 y to the 5/4 minus x to the 5/3 times y to the 1/4. What's the common factor?
X to the 2/3 and y to the 1/4.
X to the 2/3, y to the 1/4. That's right. Because we pull out the smallest exponent, right? Okay, now then for the x in the first term, it becomes just 1. How about the y?
1.
1.
Well,
Okay.
to the 1 power,
So
yeah, yes.
yes, you're right. It's to the 1. Let me write it as 4/4. Okay. Yeah,
Okay.
for the our friends, right? Just in case they're a bit lost. And then how about the x on the second term?
1.
1, which actually 3/3. Oops, no more y. I'm sorry. So the y, that's just 1 here. So now then I get x to the 2/3, y to the 1/4, y minus x. So you see, do you get it? Okay. Now then the next level is what happens if we have negative exponent. So the question you asked me earlier is basically where this go. Okay, but because I already pulled the x to the blah to the negative 2/3 out, then I only have power of 1 here to make it 1/3.
Okay.
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 Now we'll do more. In fact, the next one I'm about to do is, in my opinion, harder. Uh, number 86. Is it right? Yes, number 86. Number 86. This is the thing I'm doing here is slightly more than what you need for pre-calculus, but this is something you need at the middle of your calculus later on. So after you do certain strange derivative with what we call quotient rule in calculus, then it turns out to be this fugly. It's beyond ugly. Okay, let me write down the question first. X squared minus 5 to the 4 squared. That's the question. Hold on, I have a chat coming in. So right now we are simplifying and factoring equations. Not factoring equation, we actually never factor equation, we factor expression. Yeah, we solve equation by factoring method maybe. So right now we are simplifying expression. Yeah, we are simplifying expression. And one way to simplify expression is by factoring. Okay, simplifying has a lot of meaning. Maybe you distribute, FOIL, combining like terms, right? Okay, and one of them is factoring. So what we did here is we factor and then combine like terms. We may need to FOIL here and there, distribute here and there. Okay, now let's see. On the top, the thing at the bottom, the denominator, let's just write it as x squared minus 5 to the what? What is blah to the 4th squared?
A to the 8th.
A to the 8th, blah to the 8th. Not to the 16th, no. A to the 4th squared is A to the 16th, but if you have parentheses, it's A to the 8th. Well, because this is basically A to the 4 times A to the 4th, right? But when you multiply the same base, you add the exponent. Okay? Yeah. Maybe to better distinguish that, let's take a look how a 4 times A to the 4th squared behave. The coefficient 4, when we square it, it becomes 15. But the exponent 4, when you square it, becomes 8. Okay, I hope you can see the difference. Okay, that's for the denominator. Now let's see the numerator. What are the common factor we have? Let's see, x squared minus 5, we have to the power of 4 and to the power of 3. How many of them come out? You don't want to FOIL this. You don't want to FOIL. I mean, it's ugly enough by FOILing to the power of 4 and to the power of 3, you make it super ugly. I will factor that out. The common factor is x squared minus 5 to the power of 3. Okay, so inside, what's left? I have x squared minus 5 left, and 1 here for the yellow part. Oh, I forgot to the power of 8 at the bottom. And then how about 3x squared with x cubed 4 and 2x? I'm sorry, that's square or cube? That's a square. So how many x comes out? I think only 2x comes out, huh? X squared comes out. So what's left on the first term? If x squared comes out, then I have only 3 here. And how about this one here? That's 8x to the 4th. I take x squared out, that will be 8x squared. Are you okay? These together give us 8x to the 4th. I hope my coloring does not confuse you. And I mean, without coloring, you may not know what I did, but with coloring, maybe too much also. But it's like the middle ground is hard. I hope by doing the coloring, you know how I break it up. Now then from here on the top, outside the parentheses, I just rewrite them. This is x squared minus 5q. Okay, and then inside the bracket, I do distribution. That's 3x squared minus 15 plus 8x squared. I will simplify that later. At the bottom, x squared minus 5 to the power of 8. Now then you see that I can cancel this, right? So I have to the power of 5 on the denominator, that's the extra. So x squared minus 5 to the power of 5. Okay, that's what ended up happening. And on the numerator, I still have that x squared, and then the second parenthesis becomes 11x squared minus 15. Am I missing something? There's a minus sign, my bad. This is incorrect. This is incorrect. Terribly bad. This is supposed to be minus. This one's supposed to be minus. This is minus. So not 11, not 11x squared, that's negative, that's negative 5x squared. That's negative 5x squared. Oh, if so, then I can factor the negative 5 out. Let's go on further. So factor negative 5x squared, x squared plus 3 over x squared minus 5 to the 5th. Okay. Now, my suggestion for you when you do complicated problem, don't try to skip steps. Okay. Instead, when it is complicated, what makes you and me get overwhelmed? Usually because the way the question given to us is not well organized, or at least not well organized to our style. So what you do is like you try to break it up. Okay. Be patient with your writing. Don't try to do too many things at once. I know we are at pre-calculus, so you can do some mental math, right? Okay, but don't try to do too many things at once, because if you make any mistake, okay, if you make any mistake, especially at the beginning, then the bottom one, the later part will be screwed up. Remember my negative sign that I copied that incorrectly? Because of that extra one stroke, I messed up everything after that. Okay. Of course, when I do the grading for you, I take a look what kind of mistake you make. Right? Like right for the mistake that I made earlier, I may penalize myself 1 point. Okay, but Thomas, your final answer is very different. Oh, but I carry my mistake from here correctly earlier. Okay, but what happens if the simplification process is done in a way that when I make that mistake, the question turns out to be a lot more complicated? Yeah, that's the issue. Okay, give me a second. So yes, I make that mistake here. And if you carry that mistake properly, then I just penalize you for the mistake you make. But I know some students actually purposely make such mistake, and then the answer suddenly becomes very nice. That's also not correct. Okay. Now notice that I try to organize my work patiently. And of course, if you can organize your work, that must come from organized mind. People whose work is haphazardous, like the one I honestly hate the most. I use the word hate here. Call that hate speech, whatever you want to call it. Okay. The one I hate the most is like people who don't organize their mind, but they expect me to understand them. It's like, this is the question. They do the work here, part of the work here, another part of the work here, another part of the work here. Suddenly they get the answer here. They box it. Thomas, this is my answer. I need you to show the work properly. Okay, I need you to show the work properly, like one step at a time. Giving me the final answer defeat the purpose of giving you a lot of space. Imagine if I give you a question, if I give you a question like that, right? if I give you a question like this, and like around 20 centimeters blank, if I don't need you to show work, or I don't need you to show proper work, then I would just give you like 5 centimeters at most to give me the answer. But that's not the reason I give you 20 centimeters space there. Okay, I give you 20 centimeters space so that you can show me the proper work. Okay, not just final answer though. But Thomas, I get the answer right. Well, I need you to show me the work also, and I did everything in my mind. Okay, I give you the grade also in my mind. Okay. In other words, if you want to argue with me, get ready that I argue with you too. I mean, if you can argue with me elegantly, I give you the points, but I don't think so though. Don't forget, I've been teaching for more than 20 years. Okay. If you can think of any argument to defeat my argument, that somebody else already come up with that in the past. Okay, no need, no need. And this is actually for you, right? This is actually for you. Why you want to show your work? So that when you look back and you try to check your work, you can easily find your mistake. The way I did here. The way I did here. Right? If I didn't write it properly, then this little mistake won't be easily found and won't be easily fixed. Right? But Thomas, I get the right answer. The thing is, like in your test, you don't know what is the right answer until you see my solution. So how do you know you get the right answer if you don't show your work? There's no way. Okay, you need to show the work. Okay, let me do the last one from here. I have only, last one from here, number 90. Let's deal with negative exponent with rational exponent. Number 90. 3x plus 2 to the power of 1/2 times 1/3 times 2x plus 3 to the power of negative 2/3 times 2 minus 2x plus 3 to the power of 1/3 times 1/2 times 3x plus 2 to the power of negative 1/2 times 3. That's nasty to the max. And we get 3x plus 2 to the power of 1/2 being squared at the bottom. If anything easy from this question is the denominator. Do you think so? The denominator becomes 3x plus 2. The power of 1/2 square will be just invisible 1. Okay, now let's take care the numerator. 3x plus 2 to the power of 1/2, 3x plus 2 to the power of negative 1/2. So the exponent, the lowest exponent is to the power of negative 1/2. So what's left from the first term?
-1?
Huh? No.
Is it? Oh my God.
Negative 1/2 plus what equals to 1/2?
Oh, 1.
1, that's right, 1. Which we usually don't write, right? So I will just write 3x plus 2 to the power of 2 over 2. Let me write it that way for now. Is it okay? And then for the second part, let me be careful with my sign here. Don't repeat the same mistake. 3x plus 2 to the power of negative 1/2 already out, so it's only 1 left. So the yellow part becomes this. let's see the blue part. To the power of negative 2/3, and then the power of 1/3. So what comes out? It's 2x plus 3 to the power of negative 2/3, right? And then in the first part, I have only 1 left in the first term. What happened to the second term?
Uh,
2x plus 3 to the power of
1.
1, which actually 3/3. Let me write it as 3/3 first, and later on I make it 1. Now, how about the coefficient? 1/3 times 2, that's 2/3. This is 1/2 times 3, that's 3/2. The LCD is 1/6. Right? Denominator 3 and 2, the LCD is 6. Now 1/6 times what? 1/6 times what give me 2/3? 1/6 times what give me 3/2? 1/6 times what equals to 2/3? 1/6 times what gives us 3/2? And multiply by the reciprocal. Right? So this is 2/3 times 6. That's 4. And the one here, that's 3/2 times 6. That's 9. Okay? Okay, my daughter is next to me, trying to play with me. Okay, let me bring that 1/6 down. Oh, actually, the first yellow, I also bring it down because it's negative exponent, right? So 3x plus 2 to the power of 1/2. That's my yellow. Okay, and my blue one also go down because it's negative exponent as a factor. That's 2x plus 3 to the power of 2/3, right? And then 3x plus 2 to the power of invisible 1. On the numerator, we have 4 times 3x plus 2 minus 9 times 2x plus 3. Okay, which I will distribute and combine like terms on the top. Okay, that's 12x plus 8 minus 18x minus 27. And at the bottom, I know it's quite ugly, it's 6 times 3x plus 2 to the power of 3/2, 2x plus 3 to the power of 2/3. Now, last step, I will combine like terms on the top. I will get negative 6x minus 19 over 6 times 3x plus 2 to the power of 3/2 and 2x plus 3 to the power of 2/3. A lot of work, huh? Okay. It seems like I only did it in 4 steps, but in this 4 steps, a lot of little work put in there, right? And that's the detail that you need to pay attention to. Okay. I don't think anybody can do this in any way faster. Okay. And I think don't try to do it fast first. First, do it right first. Okay, do it in a way that you can trace any mistake you make. You can argue where this number coming from, where this number coming from. Okay, now the last one. I will accept this answer, but I believe if you look at our textbook may factor the negative out, and we'll put it right in the middle of that fractional notation. So factor the negative out. So I have 6x plus 19 on the top. Okay, and at the bottom, I copy paste. Okay, so this is the other way to write the final answer. Okay, now I hope now you see why this section is heavy. Yeah, this section is heavy because they put it together in the last, I think in the last 10 questions. In the last 14 questions, they actually put it together. I think I did like 3 or 4 problems in my lecture, and now I did 3 problems from this combo part. So a total of 7 questions done from this combo part. Okay, now how will you study when, especially when you see this kind of situation? How you study? The way you study is this. After you watch my lecture, try to see the steps I do, and then try to replicate what I do on your own. So you repeat the same questions again, maybe. Okay, you repeat the same questions, and then do it on your own once you're done, and then you compare. When you compare, you first compare the final answer. Okay, you first compare the final answer. And then you look back. Is there any steps that I may overlook? Okay. There are too many places where you can make mistakes here. Okay. So seeing the final answer only, oh, you know what? My final answer is different. So do not hurt yourself. Do not beat yourself up. Thomas, my answer is different from yours. No, no. There are too many places that you may make mistake here. Take a look on your steps. Now, the thing is, if you don't show proper steps, there's no way for you to recover or to find out where the mistakes happen, which mistake you make. Okay, is that a little mistake? Is that a crucial mistake? Is it a typo? Is it misunderstanding, a wrong notation, improper notation? Okay, too many things can happen here, such that, again, if you don't show your work, okay, even if you get the right answer, you don't know why you get the answer. Imagine if you get it wrong without any work. And there's no way for you to find out what's your weakness. Okay, the purpose we do these examples are actually to study, right? Okay, but if we want to study, then you need to be able to find your own mistakes. Okay, let's take a break. Right now it's 9, let's say 9:10. 10 minutes, we come back at 9:20. Okay, 9:20, we will go on with 1.4. See you later. If you see on my screen, I have something like this, and you don't see any movement, right? It means we are on break. Okay, you see I write the clock. This is the time we will come back. Okay, and so if you see this clock sign here on my board, sometimes I don't circle it though. And then there's no conversation, I don't speak, and there's no writing going on my screen, it means we are on break. Okay. Yeah. Now the thing is, why I say this. If you suddenly see me not saying anything, not writing anything, and you don't see this clock sign, there is a chance that either I ask you to work on something. Now, usually I have an equation maybe that is not fully done, and I say continue working on that, or your system hang, your computer or your connection stops. Okay, that's why I explain this. Okay, yeah. But if you see no sound, no movement, no writing, except that you see a clock sign, then we are on break. Okay, don't panic. Don't panic. Don't be panic. Okay, let's go on with 1.4a. Now in this section, we'll do these questions. Now, again, this is in addition to what I did in the lecture. Okay, 1.4 and 1.3 are both long sections, and they are very foundational. That's why I do a lot of problems from these two sections. And today, in the next 1 hour, I will finish these problems. Basically, I will finish most of the questions that I want to do regarding topics here. On Tuesday, however, we will cover solving equations that is not in our textbook. Okay, but that corresponds to lesson number 4. So if you watch lesson number 4, today's lesson is lesson 3, right? Okay, correspond to lesson 3. On Thursday, you will have lesson 4. Make sure you watch that first. And then we'll do more problems from that correspond to that lesson 4. Okay. Now, my plan is this. If you see that we have 7 lessons on announcement 4, we have 7 lessons. This corresponds to approximately 4 weeks lesson. Okay, approximately 4 weeks lesson. Now, but our test 1 is on week number 6. So between the end of the 4th week until week number 6, what do we do, Thomas? Okay, well, I may go on to lesson number 8, which correspond to your test 2, but there will be one day I spend to do one of my old tests. Okay, now I need you to be aware that your class is one day ahead of Monday, Wednesday class. So what I cover tomorrow will be very similar to what I cover today. Now, the thing is, when I cover an old test, for example, let's say the day before the test, the meeting before the test, right? I think your test is on Tuesday. So on the Thursday before that, I will go over one old test. Now, what I cover with you will be different from what I cover with the other class. Okay, let's say with you, I will go over from fall 2019, and then with them, I will go for spring 2020. Let's say, okay, let's say. So you may benefit to come to both of them, but I think even if you come only to one, you're fine. Now, from this 1.4, we will do solving equations. Some important principles, especially in my class, important principle in solving equation. The very first one, equal sign. The next step should be done in the next line. Okay, let's say, for example, 3x plus 5 equals to 7. What do you do next is subtract by 5, right? So the next line will be 3x equals to 2. Okay, don't write it this way. Don't write it this way. Then 3x equals to 2. When the question is that simple, maybe that's okay. But when it gets complicated and you write it horizontally like this, it gets difficult to read. It's okay for me. I mean, when I am the one reading it, I'm okay. But I see more students making mistake by writing to the right compared to writing below. Okay, so avoid writing it this way. Okay, write it this way instead. Okay, and if you see our textbook, and every math textbook, when they solve equation, the next step should be always done in the next line, not to the right of that. You see what I mean? Okay, so if I want to insist that the next step should be done in the next line, and if you don't do so, I penalize, I can. Okay, I don't really want to penalize this for something minor, but the thing is, this minor thing that we all call minor turns out to be the cause of a lot of people mistake. Okay, that's one. And on the other hand, it's also a lot harder to read when it gets more complicated. Now, that's the first principle. The next step should be done in the next line. Okay, the second principle, the equal sign, the equal signs should be straight. Now, of course, when we handwrite it, it's not easy to make it very, very straight, but at least you try. Okay, notice that my equal sign here, I try to make it straight. Okay, don't do it this way. Don't do it this way. Don't do it this way. This is the wrong way. 3x plus 5 equals to 7. 3x equals to 2, and x equals to 2/3. You see that your equal sign is not straight anymore. Okay. If I see this, I penalize you half point. Okay, it's supposed to be, the correct one is 3x plus 5 equals to 7. The equal sign should be straight. So 3x equals to 2, x equals to 2/3. Okay, next. Avoid pancaking. Avoid pancake. Especially at this level, I cannot stand people who does pancake. 3x plus 5 equals to 7. Some people like to do it this way, minus 5, minus 5. So 3x equals to 2, and then divide by 3, divide by 3. See, Thomas, I get the same answer. Well, okay, for this one, it's still easy to understand, but I have seen cases where people pancake and they pancake in a very terrible way. And for example, negative 3x equals to 6. Somebody actually do it this way. Try not to argue this way. Try not to argue, well, Thomas, I get the same answer anyway. The thing is, what you say the same answer is something you didn't know when you did the problem. You know it's the same answer after fact. But during the test, you don't know if you get the same answer. You have no answer to compare with. Okay, so the only guide, if you do it right or not, is by doing it properly. Okay, now the thing is, what happened here, why I say avoid pancake. What happened here, we actually undo the addition. That's why we subtract. Okay, now, but some people, they see this as visually entertaining. They see a number, they just add or subtract. Just like the one here. They see negative 3, they add 3. Well, no, that's actually the operation is multiplication. We undo the operation. We are not changing the sign of the number. No, we don't change the sign of the number. But Thomas, see, this is plus 5, this becomes minus 5. Well, but we are not changing the sign of the number. We change the operation. Instead of positive sign becomes negative sign, we are changing addition becomes subtraction. Just like the one here, we changed multiplication becomes division. We undo the procedure. Okay, now I know some of you were trained in pancaking method. Be aware, I will not enforce this too much. Okay, but be aware, you can easily make mistake, especially this method. This method is visually entertaining. Visually entertaining. But without substance. Hard to apply. when we have negatives, negative numbers, or we have fractions, or when we have decimals. In other words, the only time it will be easy to do is when you have integers. Okay, when you have integers only, then it is easier to deal with. And the integers has to be positive numbers. When it is negative number, it gets harder. Okay, especially when the number gets bigger, you can pancake and still get it wrong. In other words, do not rely too much on this pancaking method. Okay, I don't want to talk too much about this. Okay, if you still want to use pancake, go ahead, do it at your own risk. Okay, but if you get it wrong, don't blame it on me, Thomas, you didn't explain it right. Go back to your previous teacher. That person is the one who didn't do it right. Okay, pancake method, this method is actually not taught anywhere in any pre-calculus textbook. It may be taught in pre-algebra, but in the long run, even in the same pre-algebra method, they don't show it that way. Okay, the pre-algebra textbook, even if it shows the work, it will show it this way. So to undo addition by 5, I subtract the other side by 5. Then compute. To undo multiplication by 3, I divide the other side by 3. Okay, so not like, oh, you know what, I divide by 3. Well, dividing by 3 is something you do the next step. You don't do it in this step. Okay, what you do in the next step should be done in the next line, not at the same line. Now, this principle, however tiny, minor it is, has been the source of a big issue, especially when you deal with 1.6 later on, when we deal with inequality. Well, anyway, let's do examples. What I want to do from these sections, number 3. So I start with easy questions. Oh, you know what? Let me describe first what kind of equation we will solve here. The first one, the easy one, is linear equations. And then after that, we will do rational equations. And then we will do polynomial equations. And to solve polynomial equation, either we do it by factoring. So factoring is a technique that we learn in simplifying equation, simplifying expression, and also to solve equation. Completing the square, and then by formula. There will be some questions later on in which we have combo rational equation together with factoring. We also have absolute value equation, and then radical equation. Now today I will cover the basic parts of all of this, and then on Thursday I will go over the topics that is on the more difficult case, but still solving equation very likely not in our textbook. Now let's start with linear equation first. Number 3, the easy one. Number 3, 3x minus 2 squared equals to x minus 5 times 9x plus 4. What we will do, we will FOIL first. Equal sign should be straight, right? On the left-hand side, that's perfect squared, 9x squared minus 12x plus 4 equals to 9x squared plus 4x minus 45x minus 20. The right-hand side, I will simplify, combine our terms. Now notice that 9x squared cancel, right? 9x squared cancels. And I will move, now it becomes linear equations. So I will move this negative 41x to the left-hand side, becomes plus 41x. Subtraction becomes addition. And then the add 4, adding by 4 becomes subtracting by 4 on the other side. Where did negative 12x coming from? From here, if I have a minus b squared, that's a squared minus 2ab plus b squared. So 2 times a times b. That's how we get that. Okay, that's how we get that. Now then, furthermore, we will get, what is this? This is 29x, and this is negative 24. So the final answer will be x equals to negative 24 over 29. Okay, so you see that I try my best to have my equal sign straight. I know you may be a bit off, especially if you do handwriting. That's fine. Just don't make it too zigzag, like that. No. Don't make it way too zigzag. Okay, almost straight is fine. At least you try. Okay, and then the next step is done in the next line. That's number 3. Number 4, no, I did number 4 in the lecture. Number 5. Number 5. 3x plus 1 over 6x minus 2 is equal to 2x plus 5 over 4x minus 3, minus 13. Now what we will do here, we will multiply by the LCD. The LCD of the equation is 6x minus 2, 4x minus 13. Now I heard somebody say to me, Thomas, why don't you do cross multiply? Yeah, we are actually doing cross multiply, but do you know why we can do cross multiply? The reason we can do cross multiply is because of exactly this reason. We multiply by the LCD. So cross multiplying tells you the outcomes. Without telling you the reasoning behind that. What I'm doing here is I multiply by the LCD to give us reason for cross multiplying. Okay, cross multiply is basically this times that and this times this, right? Do you remember that? Now the thing is, why is it true? Why is it true? Well, because we multiply by the LCD. Well, how come, Thomas? How come when we multiply by the LCD, that's what we get? Let's take a look. The expression on the left-hand side, when we multiply by the LCD, what happened? This cancels, right? And we get this guy times that guy. You see that? Okay. So no, I'm not saying that cross multiplying is wrong. No, that's not what I'm saying. I'm saying that yes, we actually do cross multiplying, but do you know why cross multiplying works? Okay, why it works? Oh, because my teacher said that. Because that's what I learned in the algebra. Well, you will never know what's wrong with your teacher if you trust whatever he say all the time. Okay. Remember I said on the first day of class that I don't teach you moral, right? Because what is right for me may not be right for you. What is right for you may not be right for me. Okay. Now, the good thing with math is you can always argue your case. If you say something is correct, this method is correct, you need to, as long as you can show that this method have correct work, then that's okay, right? So Is cross multiply wrong? No, cross multiply is right, but the question is why that's right? Well, because we multiply by the LCD. Okay. Now in pre-calculus level, of course, if you say, oh, Thomas, I cross multiply right away, go for it. Go for it. Okay. The thing is, sometimes you have common denominator that you can work with such that you don't really need to cross multiply. Okay. We may see that kind of case later on. Okay. But cross multiplying, as you will also see, only works if you have one fraction on the left and one fraction on the right. So in other words, suppose I do plus something over something here, suddenly cross multiplying doesn't work. However, multiplying by the LCD is still workable. Okay. That's why you notice that I avoid saying cross multiplying. Instead, I will say multiply by the LCD. Why? Multiplying by LCD actually has more general application. Anyway, let's go on. I FOIL this. I will get 12x squared minus 39x plus 4x minus 13 equals to 12x squared minus 4x plus 30x minus 10. Combining like terms. Oh, I noticed that 12x squared cancels. If they don't cancel, then we will have quadratic equation. The way we attract that will be very different. Then I'll move the negative 30x to the right, becomes plus 35x. And then subtracting by 10, move to the other side, becomes plus 10. Now then I will get negative 3 equals to 61x, which is x equals to negative 3 over 61. Now, some people, including some instructors, they prefer to have the x on the left-hand side. And if that's what you prefer, that's fine. So you have negative 35x plus, minus 26x equals to negative 10 plus 13. That's also fine. You will get the same answer anyway. Okay, that's for number 5. Number 7. 4 over x plus 2 plus 1 over x minus 2 equals to 5x minus 6 over x squared minus 4. I will factor this x squared minus 4 first. That's x plus 2, x minus 2. Okay, now then I see, oh, the LCD is x plus 2, x minus 2. I will multiply by that LCD. So the first term becomes x plus 2 cancels, so I get 4 times x minus 2. The second term, x minus 2 cancels, I get x plus 2 equals to 5x minus 6. Now, before I go on, right now it becomes a linear equation and easy. It's quite easy to solve, right? But some warning. When I multiply by the LCD, I need to make sure that that LCD does not give me 0. In other words, x plus 2 cannot be 0. I'm sorry. And x minus 2 cannot be 0 either. Consequently, our final answer cannot be negative 2 n cannot be 2. Why? If the answer is 2, you will get undefined here. You get 0 at the bottom, and therefore undefined. If x were -2, you will get 4 over 0 here, which is undefined for this term. Okay, so when we multiply by the LCD, keep in mind that our final answer should not include the 0 of the denominator. So I have 4x minus 8 plus x plus 2 equals to 5x minus 6. I get 5x minus 6 on the left-hand side, 5x minus 6 on the right-hand side. Cancel this, cancel that. I get 0 equals to 0, which is an identity. Now, if an equation is an identity, then the solution is all real number, supposedly. Solution, the solution is all real number. Now, of course, we need to avoid the numbers that make the denominator become 0. Okay, all real number except 2 and -2. Now, if your solution is all real number except this number, in our class, we will write it this way. All real numbers, that's capital R with double line, cut off backslash 2 and -2. That's how you write it. All real numbers except 2 and -2. If the solution is identity, if the equation is identity, then the solution is supposed to be all real numbers except those numbers that make it undefined. Let's see number 9. Number 9, we have 5 over 2x plus 3 plus 4 over 2x minus 3 equals to 14x plus 3 over 4x squared minus 9. The denominator of the last expression, I factor it, becomes 2x plus 3, 2x minus 3. Oh, so from there I see the LCD is 2x plus 3, 2x minus 3. That's what I will multiply the whole equation by. Now, in the first term will give me, anybody can tell me what happened to the first term if I multiply by that blue LCD?
It becomes 5 times 2x minus 3.
That's right. Don't need to distribute it right away. Okay, so yes, you are right. Plus 4 times 2x plus 3. Right? On the right-hand side, I get 14x plus 3. Distribute, combine like terms. I get 18x minus 3 equals to 14x plus 3. So 18x minus 14x is 4x. 3 plus 3 is 6. So x equals to 6 over 4, which is 3/2. The problem is, if you look back, you see that 2x plus 3 cannot be 0 2x minus 3 also cannot be 0. In other words, we need to avoid these two numbers. We need to avoid negative 3 halves, and we need to avoid 3 halves. Right? Cross this out. The guy that's supposed to be my solution turns out to be the guy who made me undefined. So I have no solution. Okay, we can also write it this way to say no solution. Capital O, and you slash this. Okay. With this said, do not write this as 0, because that's not 0, that's empty set. Okay, that's empty set. This means empty set. 0, it's capital O, it's actually not 0, it's capital O that you slash. That's empty set. Okay, empty set means the question has no solution. Number 13, we get into solving equation by factoring now. Okay, but we apply this to rational equation. X over x plus 3 plus 1 over x equals to minus 4 equals to 9 over x squared plus 3x. The factor here is x times x plus 3. Okay, that's the LCD. I will multiply the whole thing here by the LCD x plus 3. Okay, so later on you will see the answer cannot be 0. The answer cannot be negative 3. Okay, that's a side note. Now, if I multiply by the LCD, I will get x squared plus x plus 3 minus 4 times x plus 3 equals to 9. Distribute, combine like terms. Negative 3x squared minus 11x minus 6 equals 0. You know what? Let me multiply by negative 1. Sometimes I don't even write this notation, but in case you wonder what I did there, I multiply or divide by negative 1. Basically, I switch all the sign. But notice that this is a quadratic equation now. How to solve quadratic equation? One way is by factoring. All quadratic equation, note, write it big enough. All quadratic equation that is solvable by factoring should be solved by factoring. If you can solve that by factoring, you need to use factoring method, not quadratic formula. But Thomas, I cannot do factoring for this. Well, then practice. Okay, practicing at home for trinomial with leading coefficient not 1 will actually save you plenty of time compared to if you try to solve this by formula. Okay, so let's do this. 3x squared must be 3x and x, no other way. Plus plus, so it must be both same sign and both of them plus. To have 6 is 1 times 6, 6 times 1, 2 times 3, 3 times 2. By some smell test, I know this one here will not work, and this one here will not work. Why? Because 3 and 6 has common factor, while in my original equation, we don't have common factor. For the same reason, this pair will not work because 3 and 3 also have common factor. Okay, so by little smell test, I write down all the possible choices, and I know that I can kill this pair, I can kill this pair. Either 1, 6 or 2, 3. When I use 2, 3, it works. How do we know it works, Thomas? Well, I FOIL the middle term, so that's 9x plus 2x, I get 11x. Right? Now then continue solving this. Therefore, either 3x plus 2 equals 0 or x plus 3 equals to 0. So either x equals to negative 2/3 or x equals to negative 3. But according to these, x cannot be negative 3. I have to cross it out. This is the only answer. Now, that's solving equation by factoring. Again, all quadratic equation that is solvable by factoring should be solved by factoring. One small question. How do we know that? So, how do we know if a quadratic equation is solvable by factoring? Borrowing from the material we get in chapter 2, you will see that if the discriminant d, which is b squared minus 4ac, is a square number, like 4, 9, 16, 25, so on and so forth. So you can check the the discriminant here, right? Discriminant here, if you check the discriminant, b squared minus 4ac, it must be a square number. 12 times 16 is what? 12 times 6 is 72. So when I subtract this, I get 49. So you see that 49 is a square number. That's 7 squared. Okay, so once you do the discriminant and that's a square number, stop there. Do not continue with your quadratic formula. Okay, go back and do it by factoring. Number 15. Number 15, 25x squared equals to 9. There are two ways to do this. The first one, if you want to use factoring, that's 5x plus 3, 5x minus 3 equals to 0. So x equals to negative 3/5, that's my x1, or x2 is 3/5. Now that's method 1. The second method, square root property. Basically, I apply square root to both sides. But when you apply square root to both sides, notice that if I apply square root to both sides, let me write it down first. Square root both sides. Then on the left-hand side, I will get 5x. On the right-hand side, don't forget the plus minus. Okay, don't forget the plus minus. If you apply square root property, then one of the side will get plus minus. Okay, so x equals to plus minus 3/5. Now, if you have a solution with plus minus like that, I would like you to split them. x1 is 3/5. x2 is negative 3/5. So the same to the answers we have with the first method. Now, yes, this question here is solvable by factoring, but I allow you to do by square root property. What I meant here is don't use formula, quadratic formula. Okay, if you can solve it by factoring, then solve it by factoring. Okay, don't use quadratic formula. Number 17. Number 17, we have x minus 3 squared equals to 17. Now this is, you cannot do this by factoring, but we still can apply square root property. So my x1 is 3 plus square root of 17. My x2 is 3 minus square root of 17. Number 19. They say solve by quadratic formula, but the thing is, yeah, you can use quadratic formula. It's not factorable. This is not factorable. Let me do it below. I'm sorry. This equation is not factorable. Now they say use quadratic formula, so let's use quadratic formula. Now I have a habit, if we solve by quadratic formula, my habit is I compute the discriminant first. And you will see from the discriminant here, b squared minus 4ac, you will see it's not a square number, therefore it's not solvable by factoring. Okay, 24 is not a square number. Now the reason I compute the discriminant first, so that when I plug that into the formula, I have a simple view. Negative b plus minus square root of the discriminant over 2a. Okay, maybe I write the quadratic formula here. Let ax squared plus bx plus c equals to 0. Then x12 equals to negative b plus minus square root of discriminant over 2a, where d is the discriminant b squared minus 4ac. There will be a section in chapter 2 where we do discriminant analysis on the discriminant. Okay, so if the discriminant is positive, what happened? If it is negative, what happened? If it is 0, what happened? If it is a square number, what happened? Okay, now continue from here. I will simplify. This is negative 6 plus minus 2 square root of 6 over 2. Well, I can factor 2 on the top. So x is equal to x12 equals to -3 plus minus square root of 6. Remember, I told you I always want you to split it. So x1 is -3 plus radical 6. x2 is -3 minus radical 6. Okay, that's if you use quadratic formula. Now, how about completing the square? We can solve that also by completing the square. We should try consider completing the square method if the leading coefficient is 1, this guy here, leading coefficient is 1, and the b is an even number. Now, it turns out when you have quadratic equation with leading coefficient 1 and coefficient of x is even, it will be easier to use completing the square, easier and faster. Okay, how do we do that? Let's see. The way we do that is we move the constant to the other side first. Now then we will complete the square by adding some number here. Okay, because I add some number on the left hand side, I will need to add the same number on the right hand side. Now, what number will that be? Make sure that your leading coefficient already 1. Now once leading coefficient is 1, then you take the coefficient of x divided by 2. Always divide by 2. Whatever the quotient, you square it. Now that is the number you add to both sides to complete the square. Okay, always divide by 2. After you get the quotient, you square it. That will give us x plus 3 squared equals to 6. Where is that 3 from? From that quotient 3. 6 divided by 2 gives you 3. That's the quotient. Then from here we proceed with the square root property. X plus 3 equals to plus minus square root of 6. X equals to -3 plus minus square root of 6. Which in my opinion, you can see it's a lot shorter and less work actually. We basically benefit from the fact that leading coefficient is 1 and the coefficient of the variable is even. So why it has to be even, Thomas? Actually, even if it is not an even number, it's an odd number or fraction, we still can do this. Completing the square always work, just like quadratic formula always work. Okay, but in case that leading coefficient is 1 and coefficient of x is even, then dividing this even number by 2 will still be an integer and squaring that integer still an integer. If this 6 here were 7, for example, then dividing it by 2 will be 7 over 2. Squaring it will be 49 over 4, which is fractions and harder to deal with. In that case, quadratic formula may be faster for you. Okay, I hope this way I explain under what situation you use quadratic formula and under what situation you use completing the square. Okay, both of these methods, completing the square, quadratic formula, almost always slower compared to factoring. Factoring almost always faster. The only time factoring is slower is when you are dealing with very large number or a number with a lot of factors like 24. Okay, but other than that, factoring will be faster. Okay, that's for number 19, and therefore I'm done with the quadratic equation. Let's go on to polynomial equation, like number 30. Is it number 30? Let me do number 30 first. Number 30. We have 4x to the fourth plus 10x cubed equals to 6x squared plus 15x. It's polynomial, okay? And the thing is, the degree is much higher than 2. It's not quadratic anymore. Now, the way we solve polynomial equation, it's either by factoring method or quadratic-like equation. Let's see the factoring method first. Quadratic-like equation, this is not quadratic-like equation. Okay. Now, let's see. What I will do is I will set one side equals to 0 such that I can use the factoring method. Okay, I will factor this. Oh, we have common factor x, huh? Let me factor the x out first. So this is 4x cubed plus 10x squared minus 6x minus 15 equals 0. And then I see inside the grouping, there are 4 terms. So let me try grouping method, factorization by grouping. I have that x already outside. Inside that parentheses, I will do grouping. The first 2 terms, common factor is 2x squared. I have 2x plus 5 here. The last 2 terms has common factor -3, right? Therefore, I factor further, x times common factor 2x plus 5, the remaining 2x squared minus 3 left inside the parentheses. So either x equals to 0 or 2x plus 5 equals to 0 or 2x squared minus 3 equals to 0. This is an equation with degree of 4, so we should have 4 solutions. And we will see that fact even stronger in chapter 4. I think it's chapter 4. No, chapter 3. In chapter 3, a polynomial of degree of 4 must have 4 solutions. Okay, we already have one of them. This is our x1. x1 equals to 0. x2 is -5/2. Right? Where are the other two? The other 2 solutions must come from here. Okay, so I get x squared equals to 3/2. So x equals to plus minus square root of 3/2. But this gives us radical on the denominator. Let me multiply the top and the bottom inside the radical by 2 over 2. Why? Because I want to have a perfect square on the denominator. So x equals to plus minus radical 6 over 2. That's my x34. Okay, so x3 is radical 6 over 2. x4 is negative radical 6 over 2. Now, this is for number 30. Next one, simple absolute equation. Simple absolute value equation. On Thursday, we will continue on this 1.4 with radical equations, quadratic-like equation, and another absolute value equation that is not as simple. Idea. Absolute of blah equals to distance. Distance of blah from 0. And because it's distance, it's always at least 0. Okay, distance is always at least 0. So when we say blah, absolute of blah is distance of blah from 0, the blah may be positive, the blah may be negative, but the distance is always positive. The distance from 0 will always be positive. This is distance. This is distance. Okay? Therefore, the way we solve that will be as the following. If absolute of blah equals to a positive number c, then your next step, either that blah equals to positive number c or blah is equal to negative c. A simple example. Number what? Let me see. Which number I want to do? Number 25. Number 25. So absolute of 3x minus 2 plus 3 equals to 7. Isolate the absolute value first. Absolute of 3x minus 2 equals to 4. Absolute of blah equals to positive number 4. So either blah equals to 4 or blah equals to negative 4. Okay, isolate the absolute value first, and then you split it into plus minus. So 3x equals to 6, x equals to 2, 3x equals to negative 2, x2 is negative 2/3. Oh, Thomas, what happened if the number on the other side is negative? After I isolate the absolute value and the number on the other side is negative, then there must be no solution. Absolute 3 times x plus 1 minus 5 equals to negative 11. Absolute of x plus 1 equals to negative 6. Therefore, absolute of x plus 1 equals to negative 2. But under no situation, distance becomes negative. Right? Okay. The distance of x plus 1 from anywhere will always be 0 or positive, never negative. So from here, you can just go ahead and say no solution. Okay, because absolute of something always greater or equals to 0. So what happened, Thomas, if absolute of blah equals to 0? The only time absolute of blah equals to 0 is when blah itself equals to 0. It's kind of like a trivial situation. Okay. Now, on Thursday, I will continue with radical equation. Okay. But you can do most of the problems already, especially if you already watched the lesson 3. Okay. On Thursday, we will continue with lesson 4. Please watch lesson 4 before you come to class. Okay. That's my lecture. What I do here is doing exercise. Okay. But without the lecture, you may find doing exercise here to be a bit on the other side. So far, it's still review. So even before the lecture, you may have known something already, so that you can skip the lecture and come here. What I'm afraid is I said something in the lecture that I don't say here, and you miss it. Okay, don't miss that one. I have a chat coming in. What is about quiz 1 due on 28? Let me see. If you go to assignment, oops, give me a second. According to what I see here, we have quiz 1 actually due on the 27th, not 28th. I don't know your clock, but I use Los Angeles clock. Okay, it will do on February the 27th, almost midnight. Not February 28th though. No, not February 28th. It's February 27th. Okay. So not 28th. Is doing it alone or with professor? That's something you turn in, so you do it yourself. Basically, if you look at that, okay, what's the direction say? Do as in quiz 0. Right? Okay, so basically, yeah, you do it yourself. Okay, you click on that one first and then you see the direction. Okay, but this is something you should have been able to do since the very early though. Let's preview this. Should be Mickey Mouse. Yeah, that's equation of lines. Right, and you see this from lesson 1. Okay, you see this from lesson 1. Okay, I have planned to post quiz 2 maybe tomorrow. That is due next week. Now, quiz 2-3, I think, basically cover up to lesson 3, what we covered today. Okay, then see you on Thursday.
Thank you, Professor.
Thank you.